Hi, I'm Alberto, a senior consultant at OpenCredo, and with my colleague Hieu, we are going to talk about secure pipelines, an application we are working here at OpenCredo, and how to enforce policies on a repo by making use of Open Policy Agent. Before jumping into the application details, let's take a look at what policies are and what policies as code is. A policy is a way to enforce conditions that prevent unauthorized access to resources, and with policies as code, we codify policies definitions to manage and automate their validation in different stages of software development, like automated testing and CI/CD pipelines. To automate the assessment of policies, we need to have a policy engine where we load our policies and some desired data, which we call trusted data. And when the policy agent receives a query with some input, it calls the policy, and after some processing, it returns a query result based on the policy issued. The policy agent we use in our decision process is Open Policy Agent. Open Policy Agent invented a policy language called Rego so that the policy definitions are decoupled from the business logic of the application. It works with structured data like JSON and YAML for the authoring of the policies. Here's an example of policy decisioning where we have our policy agent and we load a policy and data to go with the policy. This policy checks if a user is authorized to access a database, and the data defines the users which have authorization. When the policy agent receives a query calling the isAuthorized policy with some input data, it processes the policy and then returns a response. In this case, it's a simple false. And because the Jonathan user doesn't have access to the database based on our trusted data. In our secure pipeline application, we make use of policy as code with OPA to verify that a given repository is protected, checking for policies controls. The application is written in Golang and supports checks of repositories stored in GitLab or GitHub platforms. It can work as a standalone service, which could be run from the CLI or from a Lambda function in AWS. In the case of a Lambda function, the required infrastructure is provisioned by using Terraform configuration and triggered by a configurable schedule event. Now, Hugh is going to show us and some details of the application.
Thanks, Alberto. Hey, my name is Hugh. I'm a DevOps consultant at OpenCredo. In the security pipeline application, we've implemented 4 controls, and those are security checks at various stages of a CI/CD pipeline. So in control 1, we check if the users have permission to make changes to the CI/CD system. Then in control 2, we check if commits are signed with a developer GPG key to make sure that their authorship is valid. Then in control 3, we check if deployment keys are expired. That allows us to have a short window of attack if the keys are compromised. Then in control 4, we check if the keys are read-only to prevent them from making any changes to the repository. In control 1, the application sends a GET request to the API of a version control, and in here we fetch a list of commits since a specific date for a specific file or directory where we store CI/CD configuration. Then the application iterates through each commit and then verify their authors against the policy where we already have a predefined list of authorized users who can make changes to the CI/CD system. And then we send the result to Slack. In control 2, the application fetches from the API some information about the repository and its branches. Then it passes that data to the OPA policy where it checks if the branches are signature protected or not. Then it sends the result to Slack where the user can act accordingly. In control 3, the application fetches from the API the deployment keys of the repository, and then it passes their metadata to the OPA policy where it checks if the keys are expired or not. Then we send that result to Slack. Control 4 looks similar to Control 3 because it calls the same endpoint to fetch the deployment keys of the repository, and then it passes their metadata to the OPA policy to check if the keys are read-only or not. Then the application sends that result to Slack. In cloud deployment of the application with Terraform, we create a Lambda function to trigger the controls on a schedule. So with Terraform, we create some AWS services such as an S3 bucket where we store the config files and the policies for the application. Then we create a Lambda function to trigger the application. Then we create CloudWatch logs to store the logs of the Lambda function. And then we create CloudWatch event to run the Lambda function on a schedule. Then we create a value in parameter store, and that value is used by the application to determine if there are any changes of the CI/CD config since we last ran the application. And then we create an IAM role for the Lambda function.
We have the config YAML, where we have different blocks. The project block defines the information about the repository against which we want to run our policies. We define the platform, which is a GitHub or GitLab, owner of the project, and the repo name. On the repo info checks block, we have a CI/CD path, which defines the path to the CI/CD pipeline. It can be anything like that you use for your CD pipeline. Examples are Travis YAML, Jenkins file, GitHub workflows, and GitLab CI YAML. And then we define the policies. Here we have control 1, control 2, control 3, control 4, and then we define if any of each policies control is enabled or not, and the path to the policy rego file. And then we have the block protected branches, and here we define the name of the branches which we expect to be protected on commits, signed commits. And then here we have the block defining the notifications. If we want to enable the notification for Slack, we can just set this to true. Otherwise, we set it to false, and we only have the notifications on the console and on CloudWatch. And then here for Slack, we need to define what's the channel name that received the notification. Then we have our trusted data.yaml, which is containing the information for the policies to verify if some input is indeed trusted or not. Here we have again the repo name. This contains both the organization name / the repo name, pipeline type, and then the trusted users. Here you can have your list of trusted users that can make the changes to the CI/CD pipeline. Then we have our policies files. We have policies for both GitHub and GitLab. These are separated between each other because of the different information that GitLab and GitHub APIs return to the user. For example, here we have the policies for control 1, where we check indeed if a user is authorized to make changes to the CI/CD pipeline. So here we have all of the verification for the information, and this policy, as well as the other policies, return a JSON format containing the control name, which is in this case control 1, and then the level of notification that we want to return to the user. It could be info, warning, or an error, and then the actual response that contains the message. Like for example, here we have um, for the warning, we have that the user was not authorized to make changes to the CI/CD pipeline, and the error, for example, here is saying that the input repo name differs from the config repo, so you need to check your configuration data that details this information. For this application, we also need to set up some environment variables, and here we have GitHub and GitLab token. This depends on the platform that your repository is on. So if you are using GitHub, you only need to define the environment variable for GitHub, otherwise for the GitLab platform, as well as for the Slack token. If you are using notifications, if you enable the notification for Slack, you need to set up the notification, the token for the Slack. That's it.
This is a Terraform config we use to provision the AWS infrastructure, and in this file we need to specify which version of AWS Terraform provider we want to use, and then we need to specify which region we want to use for our AWS resources. Next, we want to create a private S3 bucket, and then we want to upload from our machine to that bucket the config file, the trusted data file, and the repo files, which are the policies. Next, we want to create a parameter in the parameter store, which is called last run, and that value is used by the application to determine if there are any new changes in the CI/CD config in the repository since the application was run. Then we want to create CloudWatch log group and CloudWatch log stream in order to store the logs of the Lambda function. Then we want to fetch some information about the account that is authorized to run Terraform, and that allows us to create some resources in CloudWatch. Then we want to create an IAM role for the Lambda function, and that role allows the function to access the S3 bucket and the CloudWatch logs, and also access the parameter store. Next, we want to create the Lambda function, and to do that, we need first create a binary of the Lambda function, and then put that binary into a zip file. Then we need to define some environment variables so that the function can access the version control APIs and also can send some notification on the Slack channel. Then we want to create a CloudWatch event rule, and that allows us to run the Lambda function on the schedule. Before we can provision the AWS infrastructure with this Terraform config, we need to build a binary of the Lambda function. So this file contains the Lambda code, and in order to build a binary of that file, we need to go to the Secure Pipeline repository and then go to cmd AWS. Then we need to define this variable, and it tells go build command to build a binary based on the Linux architecture. I want my output to be called main, and then I need to specify the source file for the binary. And that command should create a binary file for our AWS Lambda function. Now we need to place that binary file inside a zip file. So to do that, I need to run the zip command. I need to specify the name of the zip file and then the binary file I want to place inside that zip. And that should create a zip file, and that allows us to upload the Lambda function via Terraform. Now we need to define some variables for Terraform. So if we take a look at this file variables.tf, it contains description of the optional and required variables for the Terraform config. So in order to define them, we can create this file terraform.tf path. Otherwise, we would have to type the values manually in the terminal when we run the Terraform command. So in this file, I specify the name of my repository, and that is also the name of the folder in the S3 bucket, which contains the config files and the policy files. Then we need to specify the name of our bucket and then the path to the lambda zip file we've just created, then the path to the policies directory, which I have here on my machine. It contains some Rigo files for the controls, then the path to the config file and to trusted data file. Next, we need to specify the last run, and that value will be used by the application to determine if there are any new changes in the CI/CD config since the 1st of August. And I will fill these values later for the obvious reason. So in the config file, I'm going to audit this repository in my account on GitHub, and I had to specify which CI/CD config we are going to audit. And in the trusted data file, I have a list of users who are allowed to make changes to the CI/CD config. In this case, I'm the only person who is allowed to do that. Now we are ready to provision the infrastructure with Terraform. To do that, we need to go to Secure Pipeline directory, then go to Terraform, then run Terraform init to initialize the directory for Terraform, and that also downloads AWS Terraform provider for us. Now we need to run Terraform plan to see what Terraform is going to provision for us. And in here we can see the resources that Terraform is going to create for us in our AWS environment. So if you are happy with this plan, we can run Terraform apply. And that will show us the same output, but this time it will ask us if we want to make these changes. So we type yes, and Terraform should create the resources for us in AWS. The command has finished successfully. So now we are going to check the resources in AWS. I've logged into my AWS account. So let's check the S3 bucket first. It looks like Terraform created the bucket for us. And here we have the folder with the config files and the policy files. So now let's check the parameter store. Here we have the last run parameter, and it seems like the value is also correct. Now let's check the lambda function. It seems to be created successfully by Terraform. Now we can test the function. So to test the function, we have two options. We can wait for CloudWatch events to trigger the function every 12 hours. But if we want to test the function straight away, Then we can go to the test tab, and in here we need to provide some input for the function. So I've already populated the input with some values. I specified the region, the S3 bucket, and the folder inside the bucket, which contains the config files for the application. And the same input is used by CloudWatch events to trigger the function. Now we can run the audit against the repository by clicking on the test button. And it looks like we've received some result from the audit on the Slack channel. And it looks like in control 1, this user, which is Alberto, and he's not authorized to make any changes to the CI/CD config. That's because he's not listed in the trusted data file. Therefore, we've got this warning. Then the application jumps to the next commit, and it sees that this user, which is me, and it tells us that the user is authorized to make changes to the CI/CD config. And in control 2, we've got a warning saying that the master branch is not signature protected. That's because we haven't enabled that feature for the branch, and therefore we've got this warning. And then we've got some errors saying that develop and other branch were not found in the repository. That's because they don't exist. And in control 3, we check if the deployment keys are expired. So it looks like they are valid. It's because I've created them recently. And then in control 4, we check if the keys have read-only access. So it looks like the first key is valid because it has read-only access, but the second one, for the second one, we've got some warning saying that it's not read-only. That's because it has both read and write access to the repository. Now, if we run the function once again, then we should receive some new information in control 1 saying that there are no new commits since the last time we ran the application. And also, the Lambda function saves the logs in CloudWatch logs, which we can access by clicking on this link. And in here, we can see more detailed logs in case if we need to debug any potential errors or if we just need more context on the result. Thank you for watching this video. That was a proof of concept of the secure pipeline application.